Welcome to our channel. Today, we're diving into the fascinating yet controversial topic of the quantum mind hypothesis. It's an idea that has captured imaginations for decades, suggesting that the strange world of quantum mechanics might hold the key to unlocking the mysteries of consciousness. The human brain is the most complex structure we know of in the universe. It's capable of thought, emotion, creativity, and consciousness, things we still struggle to fully comprehend. Quantum mechanics governs the bizarre and counterintuitive behavior of the universe at the smallest scales. Particles can be in multiple states at once, influence each other instantaneously across vast distances, and even seemingly defy the logic of cause and effect. So it's tempting to think, could these two enigmatic realms be connected? Could the strangeness of the quantum world explain the equally strange and wonderful phenomenon of our own minds? That's what the quantum mind hypothesis proposes. Let's explore the top criticisms that this theory faces from the scientific and philosophical communities. The first hurdle the quantum mind hypothesis faces is the infamous decoherence problem. Quantum states, like superposition and entanglement, are easily disrupted by their surroundings. It's like balancing a pencil on its tip. The slightest disturbance will cause it to topple. For quantum effects to impact brain function, they need to maintain coherence. The brain is a hot, wet, and busy place. Unlike the isolated, ultra-cold lab environments, it's like a bustling city with billions of neurons firing and chemicals sloshing around. It's hard to imagine delicate quantum states surviving in such chaos. Proponents like Penrose and Hameroff argue that microtubules might maintain quantum coherence. They suggest microtubules could act as quantum computers, shielding quantum processes. However, this idea remains speculative with no conclusive evidence. Let's be clear, extraordinary claims require extraordinary evidence. And when it comes to the quantum mind, the evidence is, well, pretty thin on the ground. While it's a captivating idea, we haven't found any direct empirical evidence to suggest that quantum processes are actually involved in consciousness or cognition. Neuroscience has made remarkable progress in understanding the brain using classical physics and chemistry. We can map brain activity, identify regions responsible for specific functions, and even manipulate neurons to alter behavior. All of this without needing to invoke quantum mechanics. So, if classical neuroscience can already explain so much about how our brains work, why bring quantum physics into the picture? Proponents of the quantum mind often point to the mysteries of consciousness as evidence for their claims. They argue that since we don't yet fully understand how consciousness arises from physical matter, quantum mechanics must be involved. We need positive evidence, not just a gap in our current understanding, to justify invoking such a radical idea. Quantum mechanics is weird, there's no denying that. But just because something is strange or counterintuitive doesn't mean it's responsible for everything we don't yet understand. And that brings us to another major criticism of the quantum mind hypothesis, the concern that it's an overextension of quantum concepts. Quantum mechanics has been incredibly successful in explaining the behavior of the universe at the atomic and subatomic levels, but there's a big leap from there to saying it also governs the workings of the human brain, a system that's many, many orders of magnitude larger and more complex. This overextension of quantum concepts often veers into the territory of what's often called quantum mysticism. The idea that quantum mechanics somehow validates mystical beliefs or spiritual experiences. While it's fascinating to ponder the potential connections between quantum physics and consciousness, it's essential to approach these claims with a healthy dose of skepticism. We need to be wary of shoehorning quantum mechanics into areas where it might not belong, simply because it sounds mysterious and profound. Now, some might argue that dismissing the quantum mind outright is premature. After all, we're still learning about both the brain and quantum mechanics. But here's the thing. Classical neuroscience has been remarkably successful in explaining a vast array of cognitive phenomena. We've identified specific brain regions associated with language, memory, emotion, and even consciousness itself. We understand how neurons communicate with each other through electrical and chemical signals. We're unraveling the complex neural networks that give rise to our thoughts, feelings, and actions. And all of this is based on the solid foundation of classical physics and chemistry. So far, there's no compelling reason to believe that we need to invoke quantum mechanics to explain these processes. Think of it like this. Imagine you're trying to understand how a car engine works. Resorting to quantum mechanics to explain consciousness without first exhausting the explanatory power of classical neuroscience might be a case of premature speculation. The quantum mind hypothesis doesn't just raise scientific questions, it dives headfirst into a philosophical quagmire. One of the biggest philosophical implications of the quantum mind is its potential impact on the age-old debate about free will versus determinism. If our conscious experience is truly governed by quantum events which are inherently probabilistic and uncertain, does that mean we have genuine free will? Could it be that our choices aren't predetermined by the laws of physics, but rather emerge from the fundamental randomness of the quantum realm? On the one hand, the idea that our minds are influenced by quantum randomness might seem liberating. It suggests that we're not just biological robots, slaves to the deterministic laws of the universe. But on the other hand, it raises questions about the nature of agency and responsibility. If our choices are ultimately the result of random quantum fluctuations, what does it even mean to say that we are making those choices? The quantum mind also has implications for our understanding of personal identity, adding a new layer of complexity and mystery to the already perplexing nature of consciousness. The human brain is a computational marvel. It processes information, solves problems, and makes complex decisions with remarkable speed. But can quantum mechanics account for this prowess? Patricia Churchland argues the quantum mind hypothesis falls short. Quantum computers face limitations in handling the vast information processed by the brain. The brain is bombarded with sensory input, memories, emotions, and thoughts. It's a massively parallel processor, juggling countless operations. Quantum systems are difficult to scale up. Maintaining coherence and entanglement across qubits is a major hurdle. The brain performs logical operations, makes inferences, and understands language. So, where does this leave us? The quantum mind hypothesis, while intriguing, faces significant challenges. From the decoherence problem and the lack of empirical evidence to philosophical concerns and computational limitations, there are many hurdles to overcome. But that doesn't mean we should abandon the idea altogether. Science thrives on exploring bold new ideas, even if they challenge our current understanding. The quantum mind hypothesis reminds us that we still have much to learn about both the universe and ourselves. Thanks for watching. If you found this video informative, please like, share, and subscribe for more content on the mysteries of the mind and quantum physics.